This lesson is called Solving a Distance Rate Time Problem Using a Rational Equation. So as long as you can remember that distance equals rate times time, you should be okay. And I do agree with trying to make a table to help us out. Whoops, that time didn't quite make it there in the middle. There we go. So if distance equals rate times time, then rate is going to equal distance divided by time, and time will equal distance divided by rate. So here we have Hans. He swam 2 kilometers against the current in the same amount of time it took him to swim 8 kilometers with the current. The rate of the current was 3 kilometers per hour. How fast did Hans swim if there was no current? So we know that we're going to be setting 2 times equal to each other because it says the same amount of time. So we're going to need to figure out what our distance and our rate is so we can divide them and then set them equal to each other. So we have with the current and against the current. So we have with current and against it. So it says 2 kilometers, that's our distance. He went against and 8 kilometers with the current. So the rate that Hans is swimming is the rate that he's swimming with no current. With the current, we're going to add the current amount, which is 3. And without and against the current, we have to take his rate with no current minus the actual current of the water. Because when you're going against it, if the current is going 3 kilometers per hour, then his speed will slow down by that amount. So we're going to take distance divided by rate for each one of these. So our time with the current is our distance 8 divided by the rate that Hans is swimming with the current, which is r plus 3, and that has to be equal to the distance against the current divided by the rate when it's against the current. And we can cross multiply to solve for the rate with no current. So we'll do 8 times r minus 3, that quantity has to equal 2 times the quantity r plus 3. So be really careful that you make sure that you are distributing to each factor here. 8 times 3 is 24, 2r plus 6. So we're going to subtract 2r from 8. We're going to add 24 to 6, and then we need to divide by 6. So the rate that Hans is swimming is 5 kilometers per hour. All right, let's try another one. Oh, I erased all of my equations. Let me put them up real quick. So distance is rate times time. Rate is distance divided by time, and time is distance divided by rate. I feel like we're going to be using the time is equal to itself most often. Okay, a passenger train traveled 120 miles in the same amount of time. Yep, so same amount of time. That means we're going to be doing distance divided by rate equals distance divided by rate. Passenger train and the same amount of time took a freight train. So it looks like we have a passenger train and a freight train. The passenger train traveled 120 miles, so that looks like the distance. The freight train traveled 70 miles. The rate of the freight train was 30 miles per hour slower than the rate of the passenger train. So let's call the rate of the passenger train R, because that just makes sense. And the freight train's going 30 miles per hour slower. So we need to subtract 30 from the rate of the passenger train so we can find out. And that would be the rate of the freight train. So distance divided by rate for the passenger train is 120 divided by r. That'll give us the time. And the freight train distance divided by its rate will be the same time, and it will be the time the freight train took. So we cross multiply, which is 70r equals 120 times the quantity r minus 30. So be careful when you're make sure you distribute. So 70r equals 120r minus 3,600. Okay, so how about we add that 3,600 and we'll subtract 70 from 120 and get 50R. So we're going to divide by 50 to get, let's see, what is 360 divided by 5? 72. So our answer is 72 miles per hour. There we go. Okay, let's do another one. I know these ones can kind of be a little bit confusing sometimes. Okay, so distance. We've been using that time equals distance divided by rate. So let's see if we'll do that one again. A rowing team rowed 100 miles while going with the current in the same amount of time as it took to row 20 miles going against the current. Okay, so we went with the current and against the current. The distance was 100 with the current and 20 when it was against the current. The rate of the current is 6 miles per hour. So we are adding the rate of the current to the rate that the rowing team is rowing. So we have R plus 6. And when they are rowing against it, we're going to have to subtract 6 from their rate. So we will set up a fraction, distance divided by, not a fraction, yes, distance divided by rate, that is what I meant, is the time that they spent rowing with the current, and it's the same time that they spent rowing against it. So the time is 20 divided by R minus 6. We'll cross multiply, and we'll just distribute as we go. So 100R minus 600 going to equal 20R plus 120. So let's add 600 to 120 to get 720. And we'll subtract 20R to get 80R. We shall divide by 80. 72 divided by 8 is 9. So the rate of that rowing team is 9 miles per hour. Okay, that's the end of our lesson.